Hello everyone, this is Mr. Haynes, and I just want to give you a brief introduction to mathematical induction, which is going to be our main topic in Unit 3. So first thing I want to talk about, why do we need mathematical induction? Well, mathematical induction is a form of proof, and in math we don't just take formulas for granted. We have to show that those formulas work all the time. Now, all the time doesn't mean that it works once, or it works twice, or it works in 5 different cases we found. We have to show that it works every single time, and proof is a method we use to do that. So let's take a look at an example. For every natural number n, natural numbers, those are your counting numbers, 1, 2, 3, 4, 5, etc. But notice we're adding together this sequence of numbers. The n over here in this 6n minus 1, this is the pattern to get each successive number. So for example, if n equals 1, that's 5. If n equals 2, that's going to be 11. If n equals 3, that's going to be 17. And then over here to the right, we have a formula. This is going to be the cumulative sum of all of these numbers. Now, what does that mean, cumulative? That means you start with the first number in this series, add it to the second one, add it to the third one, add it to the fourth one, and then this should be the sum of all of those numbers. Now another way we could write this is using our sigma notation. So here's our uppercase Greek letter sigma. You'll notice that the right-hand side is exactly the same as the right-hand side here. Over here on the left-hand side, this is just another way of writing that series of numbers. Well, how can we prove that that formula works? Well, we could say, all right, well, I bet it works for n equals 1. So if I have n equals 1, that means the only thing we have on the left-hand side is one term, which is 5. Well, if I substitute 1 into the sum formula, notice that that also gives me 5. So hey, this formula works for n equals 1. Well, I say it works for n equals 2. All right. Well, if n is equal to 2, so not only do we have the 5, the first term, but now we also have the second term in the series, 11. So if we add those two numbers together, that gives us 16. Well, if we substitute 2 into our sum formula, we also get 16. So hey, formula still works. Well, what about n equals 3? All right, well, now we add together the first 3 terms in this series, and that gives us a sum of 33. Well, if we substitute 3 into our sum formula over here, we also get 33. So hey, it works for n equals 3. Well, here's the problem. How do I know this works for n equals 51? Well, you could just substitute in 51, and you could find the first 51 terms, add them together, and then put it in for that. Well, how do I know it works for n equals 37? Well, you could try n equals 37, and then someone else on the other side of the room says, well, how do I know it works for n equals 1 million? So you see what we're getting at here. It's one thing to go through and show that it works in individual cases. How can I show this works every single time? That's what we're getting at. And we're going to use mathematical induction to do that. So what does it look like? Well, mathematical induction is very similar to falling dominoes. You ever seen one of those great long series of dominoes falling? Big, giant, elaborate things. They have to zoom the camera way back so that you can see everything. Well, even if you're setting up a basic line of dominoes, well, what do you have to do? Okay, well, one thing you have to do is you have to make sure that the spacing is correct when you're setting up the dominoes. You have to make sure that if the previous domino gets pushed down, then the next domino also has to be pushed down. So for example, the first domino pushes the second domino. The second domino pushes the third domino. The third pushes the fourth pushes the fifth, etc. Well, one of our steps in the mathematical induction is going to be showing that if the previous domino falls, I know that the next domino in line is going to fall. Well, beyond that, you have this great set of dominoes, and you have everything set up to where if the first one is pushed and the second one will go down and it forces the chain reaction, well, how do you have to create the chain reaction? Simple. You have to make sure that the first domino gets pushed down. So if you push the first domino and in your setup you made sure that the spacing was correct so that every single domino would push the next one in line, then you're going to have that cascade all the way down and it's going to hit all of the dominoes. Well, when we do mathematical induction, that's exactly what you're going to have. So in our next video, in our next instruction, we'll talk about the actual mathematics. How do we actually go through the process of proving this for the series that we looked at before?